What's up, everyone? Chase Kingsbach here from Curious.3 Space.
And I'm Jacob Tifo from Alpha Omega Rocketry. We've been working on thrust vector control. Now, you'll hear that referred to as TVC, but we're just going to tell you a little bit about and how 4-H and everything has helped us in our goal of one day becoming engineers.
Yes, so thrust vector control is the angling or gimbling of a engine or your thrust or your rocket, and we want to implement that into model rockets and make it efficient and useful as possible.
Yeah, we hope to be able to make it to where anyone can take a look at our sites or videos and construct a rocket of their own. It is right now a very touchy thing to deal with, but we're cranking through and we're trying to do as much as we can. One place, though, to kind of put a picture in everyone's mind of thrust vector control would be a Falcon 9 rocket. Many of you saw the Crew Dragon launch. It was on Fox News, all news stations, where 2 American astronauts launched from American soil for the first time on an American rocket in 9 years.
Yep, since 2011, and right before the space shuttle was retired. Yeah, so this is our TVC mount. If you want the 3D files for it, you can go get it from Thingiverse, and you can find the link at
Alpha Omega Rocketry.space.
Yep, you can find the link there, and also check out the YouTube channel of his.
Yeah, and oh, by the way, if you want to, subscribe and hit that bell
so you can get notified when he does uploads. So yeah, so this TVC mount's pretty basic, and uses 9G servos, micro servos, and that's what angles the little engine, and we'll show you a little clip of it. And we're also using PID to tune and control the sensitivity of the TVC mount.
Yeah, PID, to make it real brief, stands for proportional, integral, and derivative.
Yeah, PID, proportional, looks on the present and passes it on to the integral, which reflects on the past, uses derivative to reflect it on the future, to predict the future, basically.
Yeah, so you're just taking what it's doing is it's taking a ratio from the proportional to past integrals and making a derivative, which is essentially making sure that the servo and everything keeps the angle at 90 degrees, which is being controlled by this circuit board.
Yep.
And this accelerometer. This is an MPU 6050, has a gyroscope, which is what's controlling, to some degree, the rocket and the accelerometer data.
Yep.
We also have a BME 280. This is controlling altitude and for data collecting so that we can actually see how the rocket flight went. We have an SD card module where we can throw in micro SD card and a FRAM module, which stands for ferroelectric RAM. That actually temporarily stores it because it's a solid soldered connection in the volatility and shaking of a model rocket launch.
Yep, and as our market controller, we use the TNC 4.0, which is the most powerful microcontroller out there on the market that is really easy to access and does really good for our rocket.
Now, some of you may ask, wait, that is the Raspberry Pi, if someone's techie and is thinking that. You'd actually classify the Raspberry Pi as more of a actual CPU instead of a microprocessor.
Mm-hmm. Overall, this wouldn't be very possible for us without the knowledge we've learned from 4-H.
Yeah, between aerospace, electronics, electric, robotics.
And how to solder, coding, and how to properly build a model rocket.
Yeah, and to tie a parachute.
Yeah, roll that clip.
Okay, as you saw, that is a clip from one of my videos on Alpha Maker Rocketry's YouTube channel. If you want, you can check that out again fully. But yeah, even throughout the years, we wouldn't honestly, our whole career ideas and dreams would be changed if it wasn't for 4-H.
Yeah.
I mean, I've really directed me in the path of wanting to become a mechanical engineer and major in aerospace engineering.
Yeah.
Pretty much the same with Chase. But I just want to thank you all for tuning in, taking time to watch this video. I did want to leave you with something. May we explore the universe from beginning to end.
Or from Alpha to Omega. Have a good one, folks. Bye.